All right, so if you are to go to the your Canvas and the module for chapter 7, and on the page for section 7.1, you have the links to the lecture videos as usual, but then also after that, you have a link to PowerPoint presentation. Okay? In fact, this is true with all sections of this course, but in section 7.1, you can see this PowerPoint presentation. I'm not going to go over all of these slides, because many of them we talked about this. Here is the a brief history of the mathematics and art. We talk about the Renaissance artists using polyhedra to practice their drawings, like Yamnitzer, Dürer, and other people. This is just some of the famous characters or people that appear in the history of art. Brunelleschi is known for drawing a picture of the baptistry in Florence using this small box with an eye hole and a mirror. It's a famous experiment in art. You may want to look into it if you are interested in. And this is what he did. He had a little hole and a mirror. He drew the picture and he challenged the people, passersby, to look through the mirror to see, and then he would move the mirror to let them see the actual baptistry and see how similar his picture is to the real thing, you know. And so this is what he drew. This building is still here, still there, by the way, in the middle of Florence. I would strongly encourage you to go and see that if you are able to someday. Okay, and so this is the pyramid, the visual pyramid I was talking about, and this is what the person is seeing. This is the eye, and from his standpoint, this is a mathematical model which will result in this kind of a picture, which was what I was drawing. All right, and so you have many other examples of vanishing points like this, and then these perspective. This is what I was showing you. Let's see. Is there anything else I need to explain here? All parallel. So this is 1, 2, and 3. Well, not the same as the 3 I gave you. Like farther things appear smaller. That's pretty obvious from that visual pyramid. Okay, so here's a good picture to keep in mind, right? These lines are the set of the diagonals of these square tile pieces, and they merge at this point. These are the other diagonals. They also merge at these points. And the reason they merge is because these are indeed parallel in the real world, okay, in the real world, but not perpendicular or parallel to the canvas. Okay, lines parallel to the canvas will remain parallel like this, 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 and then the lines perpendicular would meet at the principal vanishing point. Okay, changing the height will show you this. You have seen this in your notes, and then you have other pictures like that. Sorry about that. All right. Okay. Now, in the this is a picture of the picture of the Last Supper by Da Vinci. Compare that Renaissance art to the Egyptian art. Okay, so you can see that there's no depth perception here, right? Because they did not utilize those principles of perspective. Right. So now you can see all these lines. You see all those dotted lines. This is one of those, practice or studies done by a Renaissance artist, and you can see all of these lines meeting at various vanishing points. And here's a little joke from Gary Larson's The Far Side, and this is just playing with perspective, just sort of defying that principle, and makes it funny. And so using when we talk about the misuse or misrepresentation or abuse of these perspectives, you can do lots of interesting things that would cause your eyes to see something weird. Even though you could draw these things, these are not possible. Just look at these two pictures by Maurice C. Escher, and you can tell that something's wrong. The one on the right is by Escher, the one on the left is by Hogarth. And if you look really carefully, you know something's wrong, some perspective's wrong. For instance, on the left-hand side, there's a woman on the second floor giving cigarette light to a guy far, far away on the hill. Okay, so regret buying an Escher GPS. So Escher is known for drawing a picture like this one on the right, which is clearly not correct, right? If you follow these columns. Okay, these really can't possibly be real. And if you are to translate that into today's memes, you can create a meme like this one right here. Is this car on the top or on the bottom of the freeway? Right. Okay, and Escher is also known for other intriguing pieces of art, and so this is one. And he basically was an active artist back in the mid 20th century. Mathematicians sat down with him trying to explain the mathematics behind his drawings, and he really didn't have much of an idea. He somehow acquired the mathematical ideas without really formally studying mathematics. Quite a surprising thing. Here's Ascending and Descending by Escher, again in the 1960s. Here's another one, relativity. Okay, is there a top and bottom? Is there an up and down to this universe? Okay, interesting. Ants crawling on the Mobius strip, which is a strip that does not have the inside or the outside because of the twist, and so on. All right, and this is also a famous one called Day and Night. You see all these birds flying to the right? Those are white birds flying to the right. But if you focus on the black part, okay, black part, you can see this blackbird, these blackbirds flying to the left, right, from right to left, sort of in the opposite direction. And so this is called Day and Night. So these have been pictures of Maurice Escher. Now take a look at this guy. What is going on? His name is Julian Beaver, and he is a street artist, but not in the sense of street musician. He's a street chalk. I think he uses chalk to draw interesting things. Now he looks like he's on top of this world, right, of this three-dimensional sphere. But this is not what's happening. If you look at this sidewalk from another angle, this is what he drew. Okay, and he was standing right here at the North Pole. How does that work? Why is he able to make it look like he is standing on top of a three-dimensional sphere? Well, there is a reason for it, and I'll explain that when we go back to the notes. Okay, and here's another picture. These are so real, it's sort of just surprising, right? There's nothing that he dug. I mean, this whole thing is just on the street, on the concrete. And the same thing here, there is no hole there, and he is known for many of these deceptive paintings. All right, there's another whole new world that we do not know about. Okay, let me go back and finish that, finish the lecture notes. So we will go back to the notes by switching the screen. Okay, so a modern artist playing with this. There are several, but Maurice Escher is one. And I was a research mathematician once upon a time, and one of my colleagues, two of my colleagues actually wrote a joint paper on this piece called Heaven and Hell. Okay, so if you look at this picture, it's another well-known picture. Maybe it's hard to see. Let's see if I can make this bigger. Yeah. So this is called, this is based on what is known as the hyperbolic geometry. It's one of the non-Euclidean geometries you can read about in chapter 9. And you can see all the black parts representing demons and all the white parts representing angels, and they fill the entire circle. And as they go away to the toward the edges, these pictures get smaller and smaller. And there are lots of mathematics involved in this, in hyperbolic geometry. But somehow Escher was able to draw this without formal education in geometry. So that is sort of surprising in a sense. Okay, let's go back to that British artist. All right, so his name was Julian Beaver, and he does his chalk art on the streets. You should look up his art if you're interested in other art pieces he has drawn. They are not permanent art pieces that you see in museums, obviously, because these are just drawn, right? Okay, so I'm going to draw a little picture here to show you what he's trying to do in terms of the visual pyramid and the projective geometry. Okay, so this is a terrible picture, right? Bear with me, I can only draw a stick figure. So here is the human eye looking at this Earth, right? And you can see the North Pole and the equator and so on. And again, this is the visual pyramid I was talking about. You see this point here, A, this is the intersection of the Earth or the ground and this point, which is like the last point that you see in the from the perspective of this viewer. Now there's a line that goes this way, and this is the point C. Okay, so this goes through this point, which is like the top, the highest, or the point that you can see from this eye on this Earth. And here's the point where the this is like the closest point on the equator of the Earth to the eye, right? And so if you connect this point with his eye, that would extend to this point B. Okay, and so if you were to draw this picture on the side, then see this point is your A point, and this is the B point, the center of the equator, and then C is over here. And you see how much longer BC is compared to AB? That explains why such a distorted figure as this one is going to be represented by, or is going to represent the Earth, which looks like this from the viewer's standpoint. Okay, and that's why, again, AB is much shorter than BC because of the projection from that standpoint of the eye. All right, so let me summarize what I wrote here in our language, and so that should explain what I'm talking about. The picture shows why the North Pole, you see where the North Pole is to be drawn so far away from the equator. Now, if you use trigonometry, Beaver, I don't know if he actually did this or somebody else did it, or maybe he just does it by different methods. But if one uses trigonometry, then one could actually calculate the locations of these points on the sidewalk. Okay, and so there's lots of mathematics involved in this, and not just drawing silly pictures, or not silly, but artistic pictures like this. But this, I think, will show you how useful geometry is, and basically calculations involving geometry, projective geometry, and transformational geometry, for that matter, could contribute to what we know today as art. Okay, so you should be able to answer questions for section 7.1. Your quiz actually has to be turned in. This is not just an online quiz, okay? Because you have to draw pictures and you have to show me that you have learned these principles of perspective. These pictures don't have to be perfect, but I do want you to show me that you have understood these principles of geometry, and you can try, not perfectly maybe, but you can try to apply these principles in your drawing. Okay, so that's it for section 1 of chapter 7. I hope you have a wonderful day, and I will see you at section 7.2.